5.3, acids and bases. So first thing we're going to talk about is what properties acids have and what properties bases have. So acids, they form hydronium ions, H3O+, or sometimes we just think about H+, because what happens, it forms H+ ions and then does this thing with water and then it forms H3O+. This is hydronium ions or hydrogen ions. Okay, so they form hydronium ions when dissolved in water. It turns litmus paper red. Okay, so you have a little strip of paper here. It's going to turn that tip red. Okay, it's going to turn it red. The pH is going to be lower than 7. We're going to talk about the pH scale in a little bit here. It reacts with metals to form H+ ions. They have a sour taste, so you can think about citric acids and things like that. The reason why lemons have that citric or have that sour taste to them is because of that citric acid in there. This big long P word is phenolphthalein. It remains clear, so these are your key things you need to make sure that you're writing here. All right, so the thing about acids and bases is the same thing with metals and nonmetals. If you can remember one set of properties, you should be able to remember the other because they're opposites, okay? Bases form hydroxide ions. You should know hydroxide because we've dealt with it when naming chemicals. It forms hydroxide ions when dissolved in water. Litmus paper turns blue. So you got the little litmus paper. You put it into the solution and you get this blue color. It will literally turn blue right in front of you. That means it is a base. If the pH is higher than 7, it is a base. Bitter. So soap, if you've ever accidentally gotten soap in your mouth somehow or somebody put it there, soap is a base and you'll get that taste of like, ugh, you want it out of your mouth really quick. We're not talking about sour, completely different taste. Okay, slippery. So another soap again has that slippery when it's wet kind of feeling. Phenolphthalein turns pink. So real quick, I want to talk about strong acids and bases because we have weak ones and strong ones. So a lot of times people are scared of, oh, what's an acid? Ooh, you give it some weird name, people start freaking out. So vinegar is acetic acid. Sounds much scarier when you say acetic acid, but it's a weak acid. Okay, it's not gonna, it still has the same properties, it's just not gonna be as corrosive and things like that. Okay, strong acids and bases are highly corrosive and they are extremely good conductors. Okay, the reason for that is because they produce more ions. Okay, more ions. The more hydronium or the more hydroxide ions they form, the stronger it is, the more corrosive and things like that. Okay. Now let's talk about this pH scale a little bit more. We talked about it in the first few slides. We're going to draw it now. Okay, pH scale is the measure of H+ ions in a solution. So how many H+ are being formed when you put it into water? So what you're going to do first is you're going to do 0, 7, 14. The pH scale goes from 0, 7 to 14. Going this way, starting at 7, going to the 0, you get more acidic. The closer it is to 0, the more acidic, the stronger the acid. Now going the other way, 7 to 14, the closer you are to 14, the more basic. It's in alphabetical order, A, B. Okay, now 7 means it is neutral. Okay, closer it is to 0, the more acidic. Closer it is to 14, the more basic. 7 means it's neutral. Now, we have a specific type of reaction called a neutralization reaction. It's just a specific double replacement reaction. So neutralization reaction is a reaction between an acid and a base. It will always produce salt and water. The products will always be salt and water. So in your notes, you don't even have to, don't even worry about that. This right here, that is what you need to know. It will always be an acid plus base producing a salt plus water. So when acids and base react together, you always get a salt and water. Now salt is just a fancy word for ionic compound. It's not going to be NaCl, table salt, or whatever every single time. Salt means ionic compound. So an acid plus base produces salt plus water. So for example, HCl, NaOH produces NaCl plus H2O. Now, how do we know this is an acid and this is a base? Because you're going to have to do that. Okay, so how do I know this is an acid and this is a base? So let's look at it. Acids have H's in front. Acids have H's in front. Bases have OH's in the back. So an H in front means it's an acid. OH in the back means it is a base. Okay, so when they react, those two things come together to form water, and then these simply come together to form salt.